Good day, everyone. So last week we talked about the limit of a function. Now we will be discussing about the continuity of functions. Um, for this video, we will be talking about the continuity at a certain point. There are functions whose limits are not equal to the function value at x is equal to c. Meaning to say, the limit of the function is not equal to the f of c. So example, the function is a rational function with 0 over 0 indeterminate form. So it means that the f of c is undefined while the limit of the function is defined. So the limit of the function is not equal to the f of c. Another example is when the limit of the function is d in e because the limit on the left side is not equal to the limit of the right side. That's why the limit of the function is d in e. However, the f of c is defined. So that example is the limit does not equal to the f of c. So this leads us to the study of the continuity of functions. What does continuity at a point mean? Intuitively, this means that in drawing the graph of a function, the point in question will be traversed. Example, consider the graph of f of x equals 3x minus 4. Is the function continuous at x is equal to 1? Now here's the graph. Okay, the point on question here is at x is equal to 1. It means we are talking at this point. Now, to identify the continuity of a function at a certain point, we will trace the graph from the left side of the number, which is x is equal to 1, going to the right side of x is equal to 1. And it must be that there is no interruption or we would not lift our pen as we trace the graph, just like this example here. So it means, since there is no interruption at x is equal to 1, therefore the function is continuous at x is equal to 1. In the next example, we have a function g of x which is equal to 3x squared minus 4x plus 1 all over x minus 1 with a graph here. So the question is the function continuous at x is equal to 1? Now we will identify or determine if the function is continuous at this point. X is equal to y, which is here. This is a white dot. It means that at this point, x is equal to 1, the value of f of x is undefined or non-existing. So as we trace the graph from the left side of x is equal to 1, going to the right of x is equal to 1, we could see that at exactly x is equal to 1, there's a hole in the graph. Therefore, there is an interruption here, and we must lift our pen at this point. And then we could continue in tracing at the right of x is equal to 1. Therefore, at x is equal to 1, we could say that the function is discontinuous at x is equal to 1 because of the interruption. Another example here is the graph of the function h of x equals 1 over x. Is the function continuous at x is equal to 0? Now, as we trace the graph on the left side of x is equal to 0, going to the right of x is equal to 0, we can see that we need to lift our pen. Since at the left of x is equal to 0, the function goes to the value of negative infinity or downward indefinitely. While at the right side of x is equal to 0, we will start here. We will start at the positive infinity, or the function values will go to the upward indefinitely. So again, there is an interruption at x is equal to 0. Therefore, the function is discontinuous at x is equal to 0. The same function is given h of x is equal to 1 over x with a different point on question. So the point is at x is equal to 2. We will determine if the function is continuous at that point x is equal to 2. Now at x is equal to 2, it means that at this point, we will trace the graph of the function from the left side of x is equal to 2 to the right side of it, x is equal to 2, and you can see that there is no interruption. We will not lift our pen as we trace the graph of the function. Therefore, the function is continuous at x is equal to 2. Okay, so consider the graph of the function f of x. Is the function continuous at x is equal to negative 2? Number 2, x is equal to 0. Number 3, x is equal to 3. Number 4, x is equal to 5. You can pause this video to answer the graph here if the function is continuous or not at the given points here. Now we will answer the certain number or each question here. So let's start. Number 1, is the function continuous at x is equal to negative 2? So if we look upon at this point of the graph or portion of the graph, you can see that at x is equal to negative 2, there is no interruption at that point. You can prove that by tracing the graph of the function from the left of x is equal to negative 2 to the right of x is equal to negative 2. And there, it is smooth, there is no interruption, we are not forced to lift our pen. Therefore, at x is equal to negative 2, the function is continuous. Okay, for number 2, at x is equal to 0, you can see that at the graph where x is equal to 0, we can see that there is a discontinuity there. So as we trace the graph from the left side of x is equal to 0, we can see that at exactly x is equal to 0, there's a hole in the graph, meaning to say there's an interruption here, and we are forced to lift our pen before we could trace again to the right side of x is equal to 0. Therefore, at x is equal to 0, the function is discontinuous. Number 3, x is equal to 3. At this portion of the graph, we can see that as we trace our graph of x is equal to 3, you can see that there is another interruption, a bigger interruption at x is equal to 3. So from the left, we can see that the f of x is heading to the 0, while the x in the right, you can see that it is at this portion, or the f of x is equal to 4. This means to say that the x equal to 3 is discontinuous. Lastly, the x is equal to 5. You can see that as we trace it, there is no interruption, therefore the function is continuous.